Now I'm moving to final part of the video, how AI is connected to the application. I will explain the AI part of the project as one complete flow rather than going through every line individually. So the AI integration starts in pom.xml, with this dependency right here. This dependency adds Spring AI support for the DeepSeek chat model. It gives the application the classes and auto-configuration needed to communicate with DeepSeek, including the underlying chat model and the ChatClient builder that I use in my service. I also use Spring AI BOM. That is, where is it? I use this dependency. Stands for a bill of materials. It manages compatible versions of Spring AI dependencies, so I do not need to specify a separate version of every Spring AI dependency. Spring AI, originally, as I did mention in my video number 1, I built this application using OpenAI Spring AI Starter. Conceptually, the dependency would have been connected to an OpenAI chat model, and the configuration would have used properties such as Spring AI OpenAI key equal to OpenAI key. So later I replaced the OpenAI dependency with this, Spring AI Starter Model DeepSeek. I also replaced the OpenAI configuration with the DeepSeek configuration, this one right here. The important part is that most of my Java service code did not need to change. I still use ChatClient. That is one of the main benefits of Spring AI. My application depends on Spring AI's common abstraction rather than directly depending on one provider's low-level HTTP API. Spring AI provides a consistent chat model interface while allowing the underlying provider and model configuration to change. So the change was mainly OpenAI Starter to DeepSeek Starter and OpenAI properties to DeepSeek properties. Okay, so we will have a quick overview. Right now you see on the screen, this is the flow. So the TriageController receives HTTP request. Triage request holds and validates the incoming symptoms. Before anything else, I want to say you will have the code, which is on my GitHub. I will give the link to my GitHub at the end of the video. Okay, so TriageController receives HTTP requests. Triage request holds and validates the incoming symptoms. TriageService holds and coordinates the whole process. It takes the symptoms and prepares the AI request. ChatClient here is the Spring AI object, which is used to communicate with DeepSeek. DeepSeek reads the symptom prompt and patient message and selects the department. Then we have department recommendation. Spring AI converts the AI response into Java object. So again, the service takes the recommended department and passes it to DoctorService. DoctorService gets real available doctors from database. The triage response combines recommended department, AI reason, available doctors. This Spring returns as JSON. So a little bit more in detail now. So the user is sending symptom. For example, I have chest pain and shortness of breath to API triage. So Spring receives that request, the controller. So think of it like my controller is basically saying service, the triage service, Here are the symptoms. Handle the rest. The controller is part of the AI flow. You can say it is the point that receives patient's symptoms before TriageService and AiDepartmentService ever run. So my controller has one job: receive patient's symptoms through the API and pass them to TriageService. So again, we have here REST controller, which tells the class contains REST API endpoints. So the requests handled here start with /API/triage. Then there is a dependency on the TriageService because controller does not perform triage itself. It delegates the work further to TriageService. And so here Spring injects it through the constructor. So one more time, the controller receives HTTP requests and the service performs the actual application logic. This method here is important. There are several things happening here. Post mapping performs post HTTP request because the client is sending information to the application. The client is sending patient's symptoms so that the application can process them and produce a triage result. Again, for example, client could send symptoms: I have chest pain and shortness of breath. The request body triage request. So the client sends symptoms in JSON format. Now Spring needs to turn the JSON into something that Java code can read, meaning into Java object. The valid here, so the means there are validation rules, and we define them in the DTO. It should not be blank. Symptom should not be blank, and the size should be this. Then let's look at this line right here. There is request symptoms. What it does, it extracts the symptoms from DTO. So you pretty much go from the triage request to string symptoms. Then that string is passed to here. So the controller essentially says, I have received and validated the HTTP request. TriageService, now you take over. And also notice, there is no AI code in the controller. Controller does not know about DeepSeek, it does not know about database queries. It only knows receive request, pass symptoms to the service, the TriageService, and return triage response. Now let's move to the service. This class is coordinator of the whole triage process. The controller receives the request. The TriageService decides what needs to happen next. So we have the flow: TriageController, TriageService, AiDepartmentService, DoctorService, and the triage response. Again, the service annotation. This class belongs to service layer and contains application logic. It also means Spring creates and manages an instance of TriageService, so it can be injected into TriageController. Here we have we look at two dependencies. We have two dependencies, the AiDepartmentService and DoctorService, because we have two different kinds of work here. First, this one, the AiDepartmentService, it needs to figure out which department is appropriate. Then, DoctorService figures out which doctors are available in that department. So TriageService connects the AI part with the normal database part, and that is pretty much the main purpose. And then we have the constructor injection, where Spring injects both services into TriageService. So TriageService doesn't create these objects itself with new. Spring provides them. Let's move to this method right here, route patient. So the controller extracts the string from triage request and sends it here. Remember that result. I have chest pain and shortness of breath. Now TriageService receives that exact string. Department recommendation, and then the service. So symptoms are passed into the service, AiDepartmentService. So conceptually, I have chest pain and shortness of breath goes into AiDepartmentService, which goes to DeepSeek, and which goes to department recommendation. So the result is stored at the department recommendation. For example, it might contain department is cardiology. Reason, chest-related symptoms may require cardiac evaluation. The important thing is that TriageService does not care how the AI or how the AI works internally. It simply expects back department recommendation. So you might ask, what is department recommendation doing here? The object contains the structured result from the AI. You have a string, reason, and you have a department name, which is the enum. So you have two pieces of information here: recommended department and the reason, recommendation reason. You take recommendation department and you pass it to DoctorService. So suppose the AI returned cardiology, then it becomes DoctorService get available doctor by department.cardiology. Now DoctorService goes to your database and finds available cardiologist. So the AI result becomes input for your database logic. So the flow might look like patient symptom goes to AI goes to cardiology goes to DoctorService goes to database goes to available cardiologists. So the AI is not inventing doctors here. The AI only selects a department. The actual doctors come from database. We store doctors in a list, you see. Why do we do that? Because one department may have multiple available doctors. And the final step is when we have everything we need, AI department, AI response, available doctors, we create triage response. So we have department, reason, doctors. So the object contains information here from different resources, from AI, from database, and from application. The AI is responsible for department reason, database for doctors, application for disclaimer. So where does this response go? It goes back to the controller. So the flow is then TriageService goes to a triage response, goes to TriageController, goes to Spring, goes to JSON, goes to client. Spring will serialize the response, the triage response, into JSON automatically. So again, this service right here, it asks AI for department, it asks database for doctors, it combines everything into final response. Now let's go to AiDepartmentService. Again, the code will be in my repository, which the link I will include in the end of the video. This class really talks to the AI. This class has a very specific responsibility. It takes patient symptoms, sends them to the AI model, and returns structured department recommendation. This class does not deal with controllers. It does not query doctors. It does not build the final triage response. It only handles AI part. So this service tells that the class can be injected, and we inject it into TriageService. ChatClient here is very important thing. It comes from Spring AI. I think I have it here. Yes, you can read more about it following the link, or Google ChatClient API in Spring Boot. You can think of it as the object your Java application uses to communicate with the language model, which is DeepSeek in this case. So instead of manually writing HTTP request to DeepSeek, Spring AI gives ChatClient here. Then we have the constructor where Spring injects ChatClient builder into the service. A ChatClient builder build creates the actual ChatClient. You can use it when you need to call the AI. So again, Spring AI provides me with a ChatClient builder. I use that builder to create a ChatClient, which is the object I use to communicate with DeepSeek. Now we have this method, recommend department method. This is our main method. This method receives the symptoms from TriageService. I have chest pain and shortness of breath arrives here. This method sends the symptoms to AI. The ChatClient prompt begins building prompt for the AI model. The system method, that is the system prompt. The system prompt tells the model, this is your role and your rules. So I'm telling the model here that this is not supposed to, that it is not supposed to diagnose. I am restricting to these departments. This restriction is important here. Without it, the model could potentially return something like neurology, which I don't have in my application. So I define the allowed output space. These lines never invent or return another department. Return general medicine when the information is unclear. Return pediatrics only when the patient is a child. Those are all restrictions, rules that make the AI behavior. I pretty much say this is what you're allowed to do, and this is what you are not allowed to do. This is important because the output of the AI will later be used by my Java code. Then that user, this method right here, this is the actual user's input. So there are two different messages which go to the model. System message, instructions, you can say, and user message, actual symptoms. So the system message defines how the AI should behave, and the user message gives the AI the actual data to process. This part is a Java placeholder, and this line of code is the actual symptom, or replaces actual symptoms. So then we have call method. This is where request is sent. So everything before here, like user method, system method, prompt, is building the request. And everything here is pretty much sending what was built here. And then the last one, entity, department recommendation class. So I want a proper Java object. My target type is department recommendation. Department recommendation looks like that. I have a string reason and department, the enum. So I pretty much tell Spring AI, take the model's response and convert it into Java type. Then this check right here, I'm checking that the AI returned something usable. So you might ask why I have a try catch block right here. Because the AI model is an external system, a lot of things can actually fail, like network issue, AI might be unavailable, some timeout, some invalid response, maybe authentication problem, mapping problem. You don't want the entire application to crash just because DeepSeek failed. That's why. And also, I have a method like fallback recommendation. And that's the method right here, which is returned here in case there is an exception. That gives me a safe default. So the AI department service is responsible only for communication with the AI model. It receives patients' symptoms as a string. Spring AI provides the chat client, which I use to build the request. The system prompt defines the role and restrictions for the model, while the user message contains the actual patient's systems. When I call method, the request is sent to DeepSeek. Then entity department recommendation, the class converts the AI response directly into my Java department recommendation object. I also validate that the result contains a department. And if the AI call fails or returns an unusable response, I return a fallback recommendation using generic medicine. Let's quickly look at the department recommendation DTO now. So here, again, this line here means Spring AI should convert the model response into Java object. So Java object contains two things, the department and reason. For example, department cardiology, reason, the patient described chest-related symptoms. Why do we need this object? Without it, the AI could just return text like, for example, the patient should probably see a cardiologist because they are experiencing chest pain, something like that. But Java application would have to somehow read that sentence and figure out which part is the department and which part is the reason. That could become messy. Instead, we need the structured output. AI response goes to department recommendation, where converts to department and reason. Now Java can work with the result directly. So now the AI has already returned a department. For example, the result comes back into TriageService, and then this line runs, or this actually code. So now we leave the AI part for a moment and go back to normal Spring Boot database logic. So imagine it like this. AI returns cardiology, which goes to TriageService, then goes to DoctorService, goes to doctor repository, goes to database, goes to available doctors. And again, just to recollect, DoctorService receives department and finds the available doctor for that department. Let's look at the triage response because everything comes together here. The triage response is the final object. The API returns to the client. This is what it contains: reason, disclaimer, available doctors, recommended departments. So it combines information from three places: AI, department and reason, database, doctors, application, disclaimer. This is why triage response belongs at the end of the flow. So what happens after triage response is created? The triage service returns it to the controller, and the controller returns that Java object. Because this is a REST controller, Spring automatically serializes it into JSON. And that JSON goes back to the client. And that's the complete AI flow in my application. So the important idea behind this project is that the AI has one very specific responsibility. It selects the most appropriate department. The rest of the application remains normal Spring Boot logic using services, repositories, DTOs, database. And with that, we have covered the complete AI Clinic Router project from the incoming requests all the way to the final response. Here is a link to my repository. Feel free to consult the code. You can clone the project and build one yourself. And with that, that's all for now. I will see you in my next videos.